Link state advertisement. See, the protocol OSPF is a link state protocol because of the way the route is finalized. For any unknown destination, based on the link state advertisement, the route is finalized by the OSPF routing protocol using SPF algorithm. So building block of OSPF is link state advertisement, link state advertisement, link state database, and SPF algorithm. So you see, these three are the main reason for OSPF to be called as link state routing protocol. What are they? Link state advertisement. That's the very important thing. Secondly, link state database. Now, by collecting the link state advertisements from all the routers, a link state database is built. In that database, you got the complete picture of the topology. The routers know the complete picture of the topology. Over the topology map, over the map, the database, SPF algorithm is finding the shortest path to each destination. And then that shortest path will be recommended to the routing table engine. If the administrative distance of OSPF is smaller than any other routing protocol, if you have, then OSPF route will be seen in the routing table. Did you understand the last statement I said? OSPF gives the route to the routing table engine, routing table manager. Routing table manager will not immediately say, yeah, OSPF, you are the best protocol in the whole worldwide. I'll take your route. No, it's not like that. So routing table engine, the routing table manager will see if there is any other protocol, providing the same route information. If yes, then it will compare the administrative distance of the routing protocol. If OSPF's administrative distance is lower, only then OSPF route will be there in the routing table. Do you agree with this? Oh. Yeah. Whenever you got more routing protocol, the protocol whose administrative distance is less will be considered to be the best one. Okay. So very important basic building block of OSPF is LSA, link state advertisement. And you remember we also learned that OSPF is a protocol that can support a large size network. The reason for that is the hierarchy design, areas, multiple areas, isn't it? If you don't have multiple areas, then you cannot control a large database, large routing table, large number of route updates. It will be very difficult. So the size of the routing table and the database is smaller because of the areas. Multiple areas are good, but when we don't do summarization, the database will be very big. You understood? Why? Summarization on the area border decreases the number of lines of advertisement sent to other area, so that other areas will not be having detailed routes for next area. It will only have a summary. So summary route reduces the line of routes in the routing table. Do you agree with that point? When did I say summary routes? I said summarization reduces the number of routes that will be advertised from one area to another. That is my first point. Second point is, because of summarization, the routes learned in the other area will also be less. It will be decreased. The number of line will be decreased in the other area routers, not in the border. Border will summarize and send it. The number of routes will be less on the receiving area router when you send summarized route. I don't want to get into. No, we are going deep. I'm not. I don't want to get into repetition of the same thing again and again. I think you understood. Let me take you to the next level. Listen, LSA's link state advertisements will be reduced when you do summarization. If you send a reduced amount of LSAs, bandwidth will be consumed less. The receiving router CP will be consumed less. The receiving router routing table will be small in size. So summarization is important. Only when you do summarization, OSPF can support a large size network. You agree? Okay. Now, keeping this in mind, let's get into this chapter. You see, there is one big OSPF autonomous system. The problem here is you don't have many areas. As a result, you see, there are three problems, main problems the routers are facing. Number one, the routing table is too big and the memory is very less, because the routing table has already consumed all the buffer and the memory is consumed by the OSPF. So the memory has gone low and the routing table has become too big. That's one first problem we see here. Second problem is, because we don't do summarization, you see too many number of links to advertisements are received by the other routers. When you do summarization, you won't have too many LSAs. You will have only the LSA for the summary route. But because you don't do summarization, you get too many LSAs on the receiving router. See the third point, third problem. Because you are sending too many updates, the SPF algorithm is also processing every single update. As a result, the CPU of the router get consumed a lot, so router cannot perform well because the CPU is always running busy only in OSPF process. The other process of routers don't get enough CPU because the OSPF is consuming the CPU a lot, because OSPF is running always. Why always? Because always you're getting new updates. Too many. You understood the problem when there is a large OSPF network? Did you understand the three problem when you have one big large OSP? That's the reason why we make multiple areas. When you have multiple areas, the routing table of other areas will not be disturbed because you're going to send the summary route. You're going to do the summarization in the border. So the receiving router will get less number of advertisement. So bandwidth will be consumed less, CPU will be consumed less, and routing table will also be smaller. All right. But before we move further, we need to learn some details about the router type here. You see the router which is in between two areas, they got same name. How many border routers you have? Two border routers. Two ABRs, area border router. Inside the area 0, you also have a router, but the router is not a border router between the area. It is the border router between autonomous system. And we call that router as an autonomous system border router, ASBR. Autonomous system border router, ASBR. Now, why are we learning ASBR now? This is what ASBR, autonomous system border router. Why do we learn here ASBR and ABR? The reason is we'll be getting update from both. You see, the networks of area 1 will go to other area and you need to do summarization before sending, isn't it? So that is the summarization that we do on ABR. And there are some networks in the internet or in other autonomous system. If you want to summarize that, you need to do it here, isn't it? You need to do here. So in OSPF, you have two types of summarization. One is ASBR summarization, which is done for the external networks. And another one is ABR summarization, which is done for the networks of one area before it goes to other area. You understood? Yeah. So two type of summarization we are going to see now. One is ABR summarization between the areas. Another one is ASBR summarization. There is no area for the external, so the command will not be same. The command is different. You see, command, this is not properly arranged. Where is the summarization? I thought they will talk about summarization immediately after this. So when you do summarization, the LSAs are going to be reduced. And you see, when you don't do summarization, if this link goes down, immediately everyone will get the update, which is a big disturbance. Even though we have divided into many areas, the three problems that we saw in the previous chapter, first page, they will be there. You understand? So, summarization is important to reduce type 3 and type 5 LSA. Type 5 LSA can be reduced by doing ASBR summarization. Type 3 LSA can be reduced by doing ABR summarization. So I told you there are two types of summarization. One is ASBR summarization, another one is ABR summarization. This is the command for ABR summarization, area ID range, whereas for ASBR, command is different. You understood? Don't worry about the commands and all. But one thing you should be very clear that there are two types of summarization and the command is not the same. Both are configured under OSPF, but commands are not same. That's the point that you should take away from this chapter. We'll come to this chapter after some time. Let's go back to the previous chapter. So now I was talking about type 3 LSA and type 4, sorry, type 4, not 4, type 3 LSA and type 5 LSA. I told ABR summarization will reduce type 3 LSA, ASBR summarization will reduce type 5 LSA, which we need to understand how. For that, we should learn the LSA types. We should learn the LSA types. We are going to learn it today and also tomorrow. The first LSA type is called as, okay, don't forget. The reason why it is called as router LSA is every OSPF running routers, it may be DR, it may be BDR, it may be DR other, it may be an area border router, it may be an internal router, any router doesn't matter. This LSA will be sent. That is why it is called as router LSA. The advertisement that is coming from every single router is a router LSA. What is type 2 LSA called as? The reason why this is called as network LSA is the networks are distributed by the designated router in a broadcast environment. Do you agree? Hello? What, you're not sure? In a broadcast environment, you have DR, no? Whoa. What is broadcast environment? Mhm. Okay. There will be DR, BDR, no? What is the role of DR? What update? Network updates, correct. So this LSA type is called as network LSA because this LSA is sent by DR only. Type 2 LSAs are sent only by DR. No other routers can send type 2 LSA. Only a DR can send type 2 LSA. Type 2 LSA is called as network LSA. Type 3 is called as summary LSA. But there is no real connection between summary to this number type 3. Then why they named it as type 3 LSA summary? It is because this LSA only comes from ABR. Which one? That is why it is called a summary LSA. Where will you do summarization? ABR. Where will you do summarization? ABR. And this LSA is coming from where? ABR. That is why they call this summary LSA. But if you don't do summarization, even then it will be called a summary LSA. But is it really summary? No. By default, OSPF won't summarize. By default, OSPF won't summarize, will not summarize. But still the name is going to be what? Mhm. Summary LSA. Whether you summarize it or not, if you summarize it is good. Even if you don't do summarization, this LSA will be still called as summary LSA only, because it is coming from the place where summarization will be done. If you do summarization, this LSA will be less. I showed you, in the next chapter, summarization decreases type 3 and type 5 LSA. Type 3, see here it is. It's a summary LSA. If you do summarization, it will be less number of type 3 LSA. Type 4 LSA also originates from ABR. That is why type 4 is also called as both type 3 and type 4 comes only from ABR. That is why the name is given as summary LSA. But both are not carrying the same information. I didn't finish. Wait. I didn't finish. How can you get a doubt now? Let me finish. You see, both 3 and 4 LSA types comes from same border, but they are not carrying the same information. Type 3 will carry the information of one area to the other, whereas type 4 is carrying the router ID of ASBR. I know it will be too much for you now. Don't worry, I'll explain you in detail. But one thing I want to tell you, even though both are originating from same place, the informations that they carry are not same. They are different. Now you ask the question. Yes. Mm, 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 mm. See, summary LSA will only come from EBR. It will not come from any other router. Type 3 LSA will only come from EBR. It will not come from any other router. Did I answer your question? Don't worry, sir. We'll see practically. Now, about type 4 and type 5 will be confusion for you if I don't explain in detail.